Alright, hell yeah. Now welcome back. Now this one's real cool because we kind of want to do this one. E to the x plus pi, what the hell? And then pi to the x plus e. It sounds like hell no, hell no. But check it out. E, this is literally just 2.7. You know what I mean? Call it good. This is 3. You know, who cares about the 0.14? No one cares about that. So, in essence, these are kind of both close to 3, but we're just going to call this one 2. You know what I mean? Approximately 2. That's all I did. E is 2. Pi is 3. You know what I mean? And we can do this one. And this one's real cool. This one's real similar. Just to remember this one from just watching math videos all night and scrolling through. You know what I mean? Which one's larger? You know what I mean? 2 to the 3. That's 8. Or 3 to the 2. That's 9. Hey, guess what? That one's larger. But now this is crazy because it's not supposed to be this way. You know what I mean? I don't even know which one to do, but let's do 3 to the 4 and then 4 to the 3. Which one's larger? It's this one. And let's just do the calculator. 4 times 4 is 16 times another 4. Holy, this is not what I came to do. But that's 64. Okay, 64 right there. 3 to the 4, that's 3 times 3 is 9. Hey, this is 81. Okay, so this side's bigger. Hell yeah. Bigger exponent, bigger number. But check it out. Bigger exponent, smaller number. Okay, so yeah, this one's kind of cool. But at some point, if we do this plus a little x value, these things are going to equal each other. So that's exactly what's going on here. And that's pretty cool. And I think there is something unique about the E, you know what I mean, being like, 2 to the 3, 3 to the 2. This is about as good as you can get. Like I said, you can't do 3 to the 4 and 4 to the 3. You can't do it. You know what I mean? Okay. Well, and then, so let's just do this one. Now, why did I put this guy? So, this guy, he does, go check him out. He takes all the math rules and just makes he goes through the most complex stuff I've ever done. And now it's like not the way I would do it. I would just guess, you know what I mean, honestly. But I do like watching this guy because I learned so many little tricks. And you know what I mean, if it wasn't for him, he uses this trick every day. Every day he uses this trick. 2 to the x plus 3. He uses this trick. That's just 2 to the x times 2 to the 3. You know, I didn't know that. I didn't know that. And then we got 3 to the x times, whoa. See, I make mistakes all day long. All day long. Okay, once we got it to here, you know what I mean, we can do whatever you want to do. But we're going to use logs. I love log base 10. Watch my videos. I've memorized, every number log base 10. I just know them. Okay, so we're just going to do this. So the x comes down, and if you got a product, it's just going to be log plus another log is equal to log plus another log. You know what I mean? That's kind of the gist of it. All the exponents comes down. 3 comes down, x comes down, 2 comes... We're basically there. And then you just got to do the log of 2, log of 2, log of 3, log of 3. Alright, so let's do this one. It's x comes down, log base 10 of 2 plus 3 comes down. Log base 10 of 2 is equal to x. Log base 10 of 3 plus 2 comes down. Log 3. Okay, hell yeah. Now, look at this. You got an x, you got an x. These are just constants. You just call them A. You call this one B. You know what I mean? You call this C and D. Like, I literally do this for other videos. You want to do that right now? Let's do it. Let's say it's I've never done, let's not do that, we can do that later. But anyway, you want to collect the x terms. So we're going to go x log 2. Hey, let's bring this one over to the other side. And this is log 3. Hey, let's keep that one over there. But now let's move this one to here. Okay, and these are just numbers, you know what I mean? At a certain point, you just got to friggin' say, who cares? Who cares that it's a log? You know what I mean? It could be a stick. But they're just numbers. This is a number, but you have to multiply it by the x. So we're going to factor out. I don't even like to use words like factor. I just say, hey, do this. You know what I mean? And you got it. Am I even recording? Hey, let's throw some more time on the clock. All right, welcome back. And hell yeah. So now I hate writing this again. That's why my expressions, I'm just like, well, let's just bring this over to this side. Hell yeah. See, this is what I just do. I just do it. I think this is way more understandable. And then you just go x is equal to that, and you just go whoop, 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 whoop. And you did it. Okay, so we friggin' nailed. This is the shortest video I've ever made. Now guess what? Guess what? You can just replace 2 with e, and then 3 with pi. So our answer to this one is just going to be e log pi minus hyperventilating. Alright, pi log e divided by log e minus log pi. Okay, hell yeah. And if you use log base 10, you can do whatever. You could do log base, you know what I mean, Mars. I don't know. It doesn't really matter. As long, you know what I mean. But we'll clean this up. There's 2 ways you can clean it up. You use the natural log. I don't mind switching to natural log at the very end. You just change all these to natural log. So we go e, natural log of pi. And all natural log, for the love of God. Natural log of a is just log e of a, which is just log 2.7, who cares, of a, which is just a to the exponent of some number is equal to, no. 2. I forget even how to do it. This is your base, this is your exponent. 2.7 to the number is equal to a. That's why a's got to be real big, because you're taking it to an exponent. A is usually big. Anytime you're doing log, always do log base 10. Now I'm making this video too long, but always do log base 10 of a million. Just throw a friggin' million in there, and guess what? That's 6, because you got 6 zeros. And this is saying base times your exponent is equal to a hell of a huge number. That's why logs work. Every problem uses just like log of 2. Screw that. Screw that. You know, logs are very useful for huge numbers. So this is you should always write this one in just to get like on square 1. If you're using logs, you're taking a big number and turn it into 6. You could take a Google and turn it into 100. You know what I mean? I mean, you could turn it into Google, turn it into anyway. All right, let's go back to this one. Do I need to put more time on the clock? Not really. We get this done in 10 minutes. All right, so now we go. Negative pi natural log of e. And there's one more trick after. There's 2 more tricks after this. So stay tuned. Alright, so we got log e and then natural log of pi. Alright, hell yeah. So what do we know? We know that the log base 10 of 10 is equal to 1. No one knows that. I'm just telling you that. So that's also the log base 2.7 of 2.7 is 1 too. See, and then that may just mean, this is just log of e to the e is equal to 1. This is natural log, which is kind of like little base e, of e is equal to 1. So natural log of e is 1. Booyah, identity. So this is 1. This was 1. Okay, we're going to run out of juice, and I don't want to run out of juice. So let's just clean it up. Well, we're going to go up here. We're going to go x is equal to e ln pi minus pi divided by 1 minus ln pi. Alright, hell yeah. And since we can keep our original answer in the equation. There you go. Whoa. Oh, yeah, we were doing bingo and comedy the other night. Hell yeah, that was fun. People loved bingo. Alright, yep. Okay, so now we just clean it up one more time. Because, no, maybe that's cleaned up. No way. I feel like I made a mistake. Let's go back here, because, no, I guess I did good. E natural log. How the hell do you clean this up one more time? I don't know, but I do know this, is that you can just take this. I think in the video, you can just take, it's so weird. You can take pi over here minus e natural log of pi, and then divide it by natural log of pi minus 1. Now, I don't know why you can do this. Let's figure it out. I think you just multiply by negative 1 on both sides. So let's do that. So this is going to be... this is going to be negative e natural log of pi plus pi divided by, okay, this is going to be negative 1 plus natural log pi. Okay, and now you just take the pi over there, minus e natural log pi divided by natural log pi minus 1. So this is the, if you watch the video that actually had this, I might link it in the description. Probably not. But this is kind of how that they do the solution. And it's just reverse that. And, you know, to me, that was interesting. Yeah, you just multiply by negative 1 top and bottom, and those just fall out. Holy Toledo. Did I do a video in under 10 minutes? No, it took a little bit longer. You know, to me, it took 11 minutes. But alright, thanks for joining me. And guess what? That's a video.